Thank you everybody for coming. Day 2 of the Gradle Summit. Another great packed day today, lots of good sessions. This is my last one for the conference, so I'll be unwinding a little bit after this, and you can find me out at the Gradleware Lounge if you want to come and talk to me about this talk or any other talk or anything at all that you would like to talk about. So, we're here to talk about testing the build logic, and I'm encouraged to see such a full room of people here to talk about testing. So, the subject is very dear to my heart, and I like to see people interested in this, and specifically interested in testing build logic. I think it's a massively important part of maintainable complex builds, and a key value proposition in Gradle if this is possible. So what are we going to go through? If you don't know who I am, my name is Luke, Gradleware engineer. See a lot of familiar faces here, so I went through that spiel yesterday, so I need to go through that again. So, what are we going to talk about? What does it mean to test build logic? We kind of know as software developers that we should be testing as a general rule, but what does it mean to apply that kind of idea into this domain? What are the types of build logic? It's got a very general statement, build logic, the kind of general machinery that we use to build. There's different types of logic, and we need different types of strategies for testing it. So in order to think about those strategies, we need to define the types of build logic. And how do we design for better testability? If you've ever, I'm sure we all have, worked with code bases that were written or designed before testability and testing was really something that was part of the practice. Trying to retrofit tests onto these kinds of code bases is difficult. Testability is something that must be thought about up front and designed into every system. So how do we do that in our build and build logic? It's a very important part of it. It's not a second-class citizen, it's not an afterthought. Testability is something that we should be thinking about in all types of software, everything that we do. How am I going to test this? It has to be built into the design. It just doesn't work any other way. And we'll talk about some of the things that we're looking to do to make this easier upcoming. We'll go through a lot of things that you can do now and give you some ideas for testing this kind of things, but also we want to make this easier. Like everything in Gradle, we're constantly looking at it, trying to make your lives easier as Gradle users. So build testing, why test? So the core idea here is that Gradle acknowledges the fact that building software or builds are just another part of software endeavor. It's not a separate thing. We use software to automate the process of building software, and it's the same kind of software, just in a different domain. And you can't really have a debate anymore about whether testing is a good thing or not. That debate is over. So as software professionals, testing is part of what we do. It's not something left to the QA folks. As developers, we're always considering testing. So it's over. For your application code, I don't think for any serious application being developed today, you would create such a thing without having automated tests. That's just not what we do as software developers. And if we kind of combine these two ideas, your build logic is code or software, then of course we need to test that. So all software is a risk, and we mitigate risk by testing that it works. So build logic, what do we mean when we talk about build logic? Well, it's kind of a fuzzy concept, and we can think about it as being on a spectrum from general to specific. This is another key idea in Gradle, is that just as we can introduce abstractions, generalities, etc. into application code, we can do the same in our build logic. So, general build logic, flexible, adaptable, plugins, different kinds of bits that I can pull in and use, not necessarily designed to do a specific function in a specific build, but to be kind of general, usable components that I can pull together. So you see all the time, you see the plugins, all this kind of stuff. And if you were in my plugins talk yesterday, you would have seen that when you start to get into general Gradle code, there's no special behind-the-scenes world where that exists. It's a spectrum from going from the code that's in your build.gradle through to plugins. So we can take our specific logic and generalize it. We saw the mechanisms for doing that. With specific code, we're talking about the particular way that this build runs, the particular configuration of this build. So we have a Java plugin which has some defaults and some behavior out of the box, but it doesn't really say anything about this specific build right here. What are the individual knobs that have been turned here? They're doing the thing. So it's all build logic. It's just, is it general, reusable, etc., or is it specific to this particular project? As builds get more complex and larger, more logic gets shifted from this bucket to this bucket. If you think about an ants build, you have very few mechanisms for moving logic from this bucket to this bucket. Your XML just grows and grows and grows, and you have very few options for introducing abstractions to generalize. It's a key idea here. So specific build logic. More or less anything that you have in your build.gradle we could think about as being specific build logic. So adding dependencies, these are the particular dependencies I use in this project. Manually creating tasks, these are the tasks I use, etc. Just intimate details about how that specific build works. So we need to think about, what does it mean to test this stuff? How do we know this is working? Now it gets, I said it's a bit fuzzy and it's a spectrum. So we have all kinds of mechanisms in Gradle for actually applying specific logic in a general way. So here we're saying that all tasks type tests get this configuration. So we've got a kind of reuse mechanism, a kind of generalization happening, but it's still very specific logic. In this build, all the test tasks have this characteristic. So it's not necessarily the fact about whether it's reusable or entirely literal. It's, for me, my kind of rule of thumb here is that, is it deductive or literal? And by deductive, I mean that if this kind of rule was referring to something else, let me just think about the Java plugin, for example. It has a whole bunch of configuration in it that is deductive from the central model. So all kinds of rules saying that for all the Java doc tasks, the configuration is this based on something else. It's all general kind of wiring, using the same kind of mechanisms, but here it's quite specific and literal. So deductive or literal. And really, if we think about it in terms of specific to general, what we do when we design for testability in application code is take something that is literal and specific, some bit of logic, and refactor it, isolate it into something that is essentially deductive, which means I can put inputs into the process and I know what we'll expect on the outside. So I could, if I wanted to have a function that ran this kind of configuration and I wanted to test that it worked, in all kinds of situations, I would wrap this in some kind of function, make for an input into the process, run it, and I would know what to expect on the outside. Now I can test this in different scenarios. So we're taking something specific to general. We'll see more concrete examples of that along the way, but I mean, that's the idea, is the logic reusable and deductive, or it may just be reusable but still literal. It's hard, we need a different strategy for testing this kind of stuff. Know it's isolated. Okay. It can be challenging, specific build logic, because how do I test that this particular function of this particular build works in isolation without having to do the rest of the build? If that particular bit of logic that I want to test is buried in a build.gradle, how do I get access to it? How do I execute that without the rest of Gradle? It's going to be hard to isolate. And the second just really builds on top of that. In order to test that, I need lots of setup. I need the entire build, I need all the files, I need all the dependencies, just to get it and test at this particular point. If we could get to it, what would we test for? How would you actually know that that thing is working? So a common case for this, common thing people often talk to me about is say, I want to test that, let's say that my build produces a distribution. It has my libraries, my documentation, etc. So I want to test that that distribution contains everything it should. That's a reasonable kind of request, but what does that actually mean? That means that you need a hard-coded list of everything that should be in that distribution. If you have that, you may as well make that the input to the process. But we don't do that because what a build is a specification, is a dynamic specification of inputs through transformations and outputs. It's the whole idea. We don't have specific, do this to that file, do this to that file, do this to that file. We describe the process in a way that it works as the actual input sets change. So over time, the list of things that ends up in that distribution is going to change. We don't want to have to go and update the test every time. So it's a natural thing to want to think about that. I want to make sure the distribution I build has exactly what I need, but it doesn't quite work in reality because we don't have a static list of what that is. So we need to have a bit of a different approach for that. And what does it mean to test it? For any particular thing that the build produces, what does it mean to think about the build produced the right thing? If we take a simple case, the build produces a jar, a library that is used by other projects. What does it mean to say the build produced the right thing there? We do this all the time. We test it. We have unit tests. We actually test that bit of code. That thing that we are producing, we have a kind of very natural way of saying that was right. If our tests pass, if our unit tests pass on that jar, then that's a good indication that the build built the right thing. So for other things that we build that aren't necessarily code, we just need to apply that same thinking. Does it have the same functional characteristics that we require? It's not really any different, just the machinery and the mechanisms that we use is different. It's the same concept. So two different kinds of examples I think we can use. Let's talk about outputs and functions. Because builds aren't just about creating things, they're also about functions. I want to do things like release my software, generate a developer workstation, etc. Now you could argue that these are both outputs, and you'd be right. I go through a process where my output is my developer workstation, my output is my released software to the world. That's very true, but we need to think about that a little bit differently, I think. So the first comment, does the build the correct thing? The things that the archives, are they correct? Is the documentation correct? That's an interesting one. How do you test that the documentation is correct? Do the development release functions work? Can a developer open this project in their IDE from day to day? If the build is responsible for bootstrapping a development environment, is that working the same as it was yesterday, etc.? All these kinds of things you need to test. And if you have a manual process for integrating upstream changes, you need to test that as well. So instead of using some kind of dynamic dependency notation to have Gradle automatically fetch things, if there's a manual process developers go through in order to include upstreams, can they run that process? If they have to manually edit a file, that's pretty fine, but if they have a certain command they can run to go and get new dependencies, etc., then test that. So it also depends on scale here. For example, if you went to Stepan's talk yesterday morning about how we do automation at Gradleware, we would have talked about all the kinds of tests and things we use, and we're going to have a look a bit more at some of them. One of the things that we don't do is test that we can open the project in our IDEs. We're roughly 6 developers. We made the decision that this isn't necessary for us. We can deal with the case when this breaks, somebody will fix it. It's not a huge stop the world event for us. If I had a team of 200 developers, I'd think very differently about that. If developers can't open the project in their IDE, that may be a huge blocker for productivity. So just the fact that a build does something doesn't mean we have to test it. Testing is always a cost-benefit equation. So testing outputs, we kind of hinted at this, that really testing outputs is automatically done by your users. If it's broken, they'll tell you. But we want to catch that before it happens. That's the whole point. Don't release broken stuff to the users. But sometimes, depending on context, of course, that might be okay. Who are your users? How quickly are you going to get that feedback? If it's cheaper to do it that way, and by users, if you're doing a website and your users are actual users, not other developers, I don't recommend this at all. But see, it's the same concept. We're just trying to get that feedback faster before the users do, if necessary. So, what are some ways to do this? Probably the biggest one is to always use something that is as close as possible to what the users get. So avoid trying to build differently during development and test or any part of the process. Try and be as close to as possible to production. Therefore, you're avoiding a situation where the way that the software is built for development works, but not for production, or the documentation, or etc. This can be really tricky. It often takes a lot of work, a lot of hard thinking to achieve, but this means you automatically get more testing just by going through the build process and downstream steps. Second is really an extension of the first, but slightly different. In the first one, we're saying that to use something, build it once, essentially, and promote it downstream. Don't rebuild at each step. Every time you rebuild, there's a risk that something changes and goes wrong. And the second is saying that every time you build, no matter for what environment, try and make it as close to possible as the final release. Avoid variation as much as you can. And for non-functional characteristics, test for them explicitly. So back to our jar example, if we have a library, we're producing a library, but we're also producing a distribution. So let's take Gradle, for example. Gradle has functional characteristics. Does Gradle run, etc.? Whenever we build Gradle, we have to make sure that's the case. But we also want to make sure that our distribution that we provide is good. It has the documentation, it has all the necessary bits. So calling those things non-functional characteristics. So you need to be a bit inventive about this stuff. So in Gradle, we produce 3 different distributions. So we produce 3 different distributions: a bin distribution, source distribution, and a combined distribution. Now, there's a few things we need to make sure don't happen. Let me back up a little. As part of our build, we have a whole bunch of specifications of what should go into the build, what should go into the distributions. So, different things from around the place, different things. Here's the documentation coming in, our launch scripts, all of the libraries, etc. go into our distribution. So any build that's building something will look similar like this. But how do we test that this configuration, a configuration of what gets included, it works? And there's a lot of logic wrapped up in here. Now, if I was to say, okay, well, I'm going to unit test this. I want to test that each line of this code runs correctly. Think of all the setup I would need. I can't do this in any other context in this particular build. I need all that set up. I would need to know what all the inputs are. So every time the inputs change in my build, I have to go and update my tests. Doesn't quite work. So what we actually do is part of the build, we have unit tests that will build those distributions, unpack them, and go and look for specific files in there that we think are important to have in there. It's not every file, but if something goes wrong here, we know something has gone pretty wrong. So we know we can check in here that the binary distribution, we have a standard check that we run for all our distributions, that it contains a license file, contains the status, the binaries that you can use to start Gradle, etc. A bunch of different things. So this isn't a comprehensive list, it's just that if those are there, then think the general machinery is working pretty well. Test that, so that's the binary distribution. We also test that things like, okay, so there's no duplicate entries. We go through these zips and look for any duplicate files in our duplicate zip entries, etc. We check, no, we don't do that here. The source distribution of Gradle actually contains the build source at that snapshot. It's actually buildable, that Gradle build. So we actually get that, unpack it, run the Gradle build from inside that source, make sure that particular source distribution builds, and then actually test that it built Gradle itself. So I had to go through some steps here and some build out some testing machinery to ensure this happens, but this tells us that for every build, our distributions are actually working. So if I go and change something in the distribution, I can run which actually, I'm not sure what I've done here. If we look at the configuration of our test task in Gradle, this is the test task that's going to run those tests we're just looking at, specifying that the inputs to this test are the actual distributions, therefore before I run the test they get built. Extend stuff. So we're not really unit testing the code that we're building, we're unit testing or integration testing the outputs. So you have to be a little bit inventive in that, configure the build so that before the test task runs, the distributions actually get built, and configure the test in such a way where it knows where the distributions are to go and test them. You can apply this kind of concept to anything that the build is testing. Sometimes you just have to have a good think about, what does it mean to test that particular output? What are the things that I could check for? For us, the source distribution, does it actually build? The bin distribution, does it contain all the relevant binaries, or some of the relevant binaries, as a smoke test? And this gets run on every single Gradle build. Every single time we commit, this runs, etc. So we have very early feedback if something's broken. By the way, please feel free to ask questions about more. If you want more detail on any particular point here, interrupt at any time. So, hard to comprehensively test, because this case was is simple enough. We had another output, we just unpacked it, looked at it. We didn't test every aspect of it, but we picked the important ones. And some functional characteristics as well. We tested that that source guide could actually run. So what are some more examples? Well, IDE provisioning. If your build actually bootstraps a developer workstation, you're going to want to make sure that happens. What about the release process? That's something that the build runs as well. If you're releasing, say, every 6 to 8 weeks, and you're only running this process every 6 or 8 weeks, that's a long window when things can go wrong. And you only find out at the end of that release cycle. And the whole development environment setup. So one aspect of this can be a very tricky problem if your runtime environment is complex. If you haven't heard of it, it's definitely worth looking at tools such as Vagrant. So Vagrant is a recipe-based virtual machine provisioning tool. You can specify in a text file declaratively what is the format of a virtual machine and use it to start it up, which means you have a central definition of what the development environment is. That definition may be, okay, it's Linux, it has this version of Java, it has Tomcat when it starts, I take the WAR file that was just built to the build and push it over there. And it just kind of minimizes this problem by giving it self-containing the development environment. So if you test it and run it on the CI server, and you can bootstrap that development environment, that's a good indication that developers can too. So Vagrant is something to look at if you haven't looked at it. So testing functions, something that's a bit more complex than a distribution. The general strategy is to exercise it often. Don't let any function sit there unrun, because it will decay and break. So run it as often as possible and smoke test. So a good example of this is having a nightly build process. That's if you aren't releasing, not practicing continuous delivery and have a release, even if it's just a week long, I would say a week is too long to let the release process sit there unrun. So have a nightly build that simulates the entire release process as close as possible. Ideally, that is actually going to release fully to production like any other build. So this kind of the idea of continuous delivery here is to always be doing this. So you don't have periods where things can actually potentially go wrong. A simple one, if you are using the Gradle IDEA or Eclipse plugins to generate IDE integration. In the simple case, for a simple Java plugin, you can rely on this just working. But in many cases, in more complex projects, you'll see in Peter's talk this afternoon, you can tweak and customize what these plugins do. You can change the way that it projects the Gradle project to the IDE. So you write your own code in here, and you might put something in there that actually means that IDEA or Eclipse can't open these guys. So if you're doing heavy customization of that, then how would you do that? How would you test that you can check out the Gradle build, run Gradle IDEA, and then open it in IDEA? A good thing to look at is Sakuli. Sakuli is a general GUI automation testing tool. Think Selenium, but for the desktop. You can automate any GUI-based process with Sakuli. It's slow, it's clunky, you don't want to test your application stack with this, but for doing something like running Gradle space IDEA, and then automating the process of trying to import that project into IDEA or Eclipse, works very well. It's a good tool for just generally testing the kind of bootstrapping the builds do. Similarly, if you're using, in your Gradle build, you're using Vagrant, something like that, so your Gradle build produces a Vagrant file, actually test that you can execute that Vagrant file, start the VM, and your application does start in that development environment. Have a CI test that actually does this every day. And I'm saying, not always easy and clean like unit tests. You need to be inventive, you need to get your hands dirty, do whatever it takes to test it. It's more important that these things are tests than you have nice, clean, simple testing strategies. All right, so we try and practice this with our release process. So every single night, our nightly release process does 99% of our full production release process. So at any particular points, I can run a nightly build. This will actually use pre-built versions of Gradle from earlier in the pipeline, pull them down, package that stuff up, run some final tests on it. It'll rerun some basic smoke tests, upload it to our website. After it goes through that process, we then this is a separate Gradle build that actually handles that promotion process of taking Gradle and uploading it to Amazon S3 and our website, etc. So after that happens, we test, well, is what was just uploaded actually valid? So what we do is we actually go and download the version of Gradle that was just uploaded. Some stuff here, we pass in the URL to go and get it from. We get it, set up a bit of a development space, and then pull out one of the samples from the distribution, which is using the tooling API. If you haven't heard of the tooling API, it's the kind of embeddable Gradle API. And we use this to actually try and run a Gradle build with that version of Gradle that we just built. So if we can do this with the version of Gradle that was just uploaded, if we can use the tooling API to download itself and run the Gradle build, then it's a good indication that that build actually works. And this happens every single night. And we've built up libraries and infrastructure around this, continually making it easier. We're constantly investing in this testing infrastructure, just like we're investing in the Gradle application code. So it's software to build software, etc. Yeah?
Do you know when you want to expose that as a public API or library?
The tooling API?
For example, the integration spec, integration test spec class.
So this guy is basically not doing much more than forking processes. Underneath the hood here in distribution spec support, it's basically downloading Gradle, forking, calling its Gradle guy. So low level here, there's kind of more stuff going on, but you know, this is a very important test to us. You know, we've abstracted it to a high level so we can read what's going on, etc. Your specific point, so that's not being in use here, but what you're talking about is coming up later.
Oh, okay.
Yeah. So I guess the thing, you always need to think about how to do this. There's not really out-of-the-box solution. And I think in, as Hans was saying last night in the keynote, continuous delivery and continuous deployment is not a cookie-cutter exercise. You need to constantly be looking at what to test and what to automate, and investing in the testing of that. So the only thing that changes between our nightly build and the release build is one line of HTML on the website. It says that this is a final release, not a nightly release. Everything else is done exactly the same way. And we run this regardless of whether there's changes every night. And we also, I imagine Justin will be talking a lot more about this in his talk this afternoon. But I mentioned that let's not quite what I want. Wi-Fi goes from being extremely fast to extremely slow. So in our build pipeline, we actually build Gradle once with Java 1.7 on Linux in our blessed cleanroom build environment and pass those binaries through to our different other environments that Gradle is certified for. The Java 1.5 on Linux, there's some Windows stuff down here, didn't go so well. Not sure who did that. All different environments there. So this is just that idea of that when we're testing it, it's something that's exactly like what's going to go into production. We don't rebuild on Java 1.5, we don't rebuild on Windows, etc. So in the whole testing pipeline, it's the same thing, which reduce the space. And we discovered a whole bunch of issues when we first put this in place. We used to rebuild on different environments, and we found that Gradle actually did behave differently if it was built on Windows. Because we have native integration and a whole bunch of different things, so it does matter wherever possible. Alright, so every single release we go through, every time we go through the release process, one of the things we do is sit down and look at, okay, what more could we test about this? What are some other things that the build is doing? Because if at the end of the day, this is the most important thing, that our Gradle build puts out working Gradle releases. So we don't consider this done. It's something that is always evolving, always improving. And that's the only way to approach this kind of thing. All right, so that was talking about the general stuff. So specific build functions, testing this specific build. Now, we can't really get into the low-level details to test there. There's a lot of stuff in the Gradle build files that we're kind of testing at a very high level by testing the Gradle releases work. Now, we want a different way of approaching this. Oh, sorry, before I go there, on specific logic, cost benefit is always the thing you should be thinking about. More tests is not necessarily better. Always look at the test. What is it testing? Is it needed? With these kind of tests, if you're compared to unit tests, are brittle and do produce false values. try and work to minimize that, but just because they do have intermittent failures because of network issues or something like that, doesn't mean they get culled. And don't overestimate the cost. Once you get started down this road, it's not that difficult. Get into this mode of thinking of just testing everything. And don't underestimate the benefits. It's a huge part of being able to release frequently. All right, general code. So I was talking about Gradle gives you tools and constructs to generalize logic. This is one of the key ideas. And we can use this for reuse and all the other things that we've seen so far. I did a talk on plugins yesterday on being able to provide nice configurable models. A talk on plugins for talking about standardization, but also just for testability. Just for a large complex build, just for breaking units down into general pieces that I can unit test. So I don't have to test at this high level, I can test individual bits down here and reduce the amount of testing I need to do up here. So what are some of these mechanisms? Well, plugins. Plugins are a very simple container-like concept in Gradle. You don't have, plugins can be as lightweight and as simple as you like. It can be one line of Gradle script, or they can be very large. That's a way of mechanism of just getting stuff out of a build.gradle into a class that I can unit test. Configuration rules, task.withType, etc. If I can actually shorten the amount of code, then I can just unit test that code. Configuration actions. This is best seen by example, I think, but Gradle in many cases allows you to pass an action to the API which does something with an object. It's an interface action. It's a simple method that takes something. So we can, that's just a bit of configuration, an action. Just a bit of specific configuration. We can model that as a separate class and unit test that class away from the build. And of course, just general domain modeling, introducing these concepts like source sets, and we'll see coming up with browsers, etc. We can generalize the code to unit test it effectively. And that's just the same type of concept, exactly the same thing we do in applications. So for a large complex build, we use these constructs to turn it into more of a program than a set of scripts. That's the way we should think about a Gradle build. It's a program. The script is just an interface, a kind of end user programming environment into the program of the build. And why? Because we have good tools and techniques for testing programs. Once we get into this mindset, it becomes very natural to think about the tests that we write. Making code more general makes it testable. We can control the dependencies. For exactly what this bit of code needs, we can isolate its collaborators. It's a smaller scope. Isolate individual units, we can test just the function that that unit provides. And more isolated from external change. This is what I was getting at before, talking about trying to test what goes into a distribution. We don't want to test a concrete list of outputs because that may change over time. If we isolate and externalize things, we can create contrived inputs in order to test the outputs. And those contrived, that test data set doesn't change as the real data changes, the real set of inputs changes. But because we've tested the logic inside this unit, we know it's okay for that larger set. So I like to think about testing Gradle logic in terms of three groups, the kind of three groups that we're familiar with: unit, integration, and functional. It gets a little blurry between these, and you can certainly think about it in different ways, but I'm going to present tests in these particular three groups. So in a unit test, we isolate the code as much as possible. One particular unit, test the smallest bit of code we can. Integration test, we're testing boundary assumptions. So this happens all the time. If you think about a Gradle plugin, it's integrating with the Gradle model. It's using a whole bunch of objects, it's creating tasks, talking to the source sets, etc. We're integrating with the rest of that. And we want to test that we make sure that we're driving that API the way we think we are. So when I do this to the Gradle model, do I get this as an output or a result? And functional. If somebody puts this code into a build, does it actually work? Can they actually build with it, and does it do what it's supposed to? So as soon as you talk about testing build logic and you have to run a build, that's now a functional test or an acceptance test. A top-down test. Unit tests are cheap. Integration tests slower, and more real collaborators, more external change can happen. And functional tests, just like web tests, are slow, expensive, and sometimes awkward. So what we want to do is basically more unit tests, a few integration tests, and a few of these as possible. All right, so to have a look at these different kinds of tests and how they work in Gradle, we're going to use a case study. Now, I've developed a plugin that executes JS test driver. Now, JS test driver is developed by Google. It's basically a Java-friendly JavaScript unit testing tool. Integrates with IDEA, Eclipse, etc. Tries to make running JavaScript unit tests as easy as it is in the JVM. To automate it, however, it's not as easy. We need to coordinate several processes. It actually ends up being effectively three processes if we don't count Gradle. We have a JS test driver server, a JS test driver test runner, and we need some kind of browser to run the tests in. So we're going to coordinate all of that. And a good plugin for JS test driver adds some Gradle-like conventions, makes it easy out of the box, etc. So we want to develop a plugin that does all this and see how we can test it. So how it works, if we just have a look at the plugin initially, this is just having a look at JS test driver, some JavaScript over here that we want to unit test. JS test driver is designed to be used for pure JavaScript unit testing. We're not doing DOM stuff, we're not doing jQuery, we're just testing pure JavaScript logic. You can do that stuff too, but this is what it's designed for. Excuse me. I need a couple of things. I need my test JavaScript file. I need a configuration file for JS test driver which says where are the tests and where's the code to test a bunch of things in here. I'm not so interested in the specifics of JS test driver, more so how to drive it. And after I've developed my plugin, this is what I get. So I have a JS test driver plugin. I need JS test driver. It's a jar. It's implemented in Java. I need to configure my JS test driver plugin to say that which browser are you going to use to actually run the tests. So JavaScript tests have to run in a browser-like environment, so we need some way of doing that. And we're going to have a look at this machinery. And I configure a specific JS test task here, and I say that this is my config file, and I'm testing these guys. So with all this in place, I can run Gradle JS tests. There's some output from JS test driver. Ran my tests, everything was fine. So what happened in the background was that we launched the JS test driver server, then we actually launched Chrome and connected to it. Yes, it's Chrome. And then launched a JS test driver runner and made all that work. So a couple of things in play. We have all that JS test driver mechanics. We need to make sure that we're launching that correctly. But also, when I do this kind of configuration, is the right thing happening? So there's the actual programming JS test driver, and then there's creating the Gradle plugin. Let me just make that fail to show that it actually is running tests. Failing JavaScript test.
Luke?
Yes?
Is that testing that whether you have Chrome installed on the machine?
So
Does JS test driver provide a headless browser?
it doesn't provide a headless browser. I'm actually using Selenium to point Chrome at JS test driver to do this. A lot of people use Phantom JS with test driver, so which is completely headless. But Phantom JS introduces it's easier to automate Chrome than Phantom JS, which is why I used it in this demo. So just focus on one thing. So in this case, yes, you would need Chrome installed. This code is going into a plugin that I'm developing that will work with Phantom, so you will be completely headless and portable. All right. So the types of tests we need for this plugin. Unit tests. Is each class in my plugin, we'll see that I've got quite a few, internally coherent? Is it just, forget about Gradle, forget about everything else, just think about this particular class, is my code actually right? Are we doing what we expect to be to the collaborators? This is when we mock things out and we just see what methods were called on the collaborators, etc. It's traditional unit test stuff. Integration tests. Can we actually correctly drive JS test driver? If I put this stuff together, does JS test driver start? All that kind of thing. Am I integrating with that correctly? It's a separate process. Are we integrating with the Gradle model correctly? If when I apply the JS test driver plugin, does the JS test driver extension get added to the Gradle project? All that kind of thing. And functional. If I run Gradle JS test on the command line in a build that uses this plugin, does it actually run the tests? Etc. Full stack from the very top. Exactly the same thing as using Selenium to go and click buttons in a web browser. So let's just have a quick look at the plugin code. At the very top is my plugin. And one thing it does is it gives me a JS test driver extension to the DSL, which we saw here, which allows me to configure some defaults for every JS test driver execution. All right, so I've added something to the domain language. And all this guy basically is if you're in my plugins talk yesterday, I mentioned convention mapping and derived configuration. This is all that's going on here. From our extension, we have some properties. So these are things that you can configure globally. What is the port that JS test driver should run on? How can I create a browser to run the tests with? We'll look at that. And what is the version of JS test driver that I should use? So inject that into the DSL. Now behind the scenes, we map that model into the task execution layer using this mechanism. So that's all this is doing here. It's a bit wordy. So then we're saying for each JS test driver task that we create, hook these things together. Make its defaults the model. So that's all our plugin really does. Now, this would be a capabilities plugin, not a convention plugin. If you're in either of my talks, we're going through that split, and Adam just spoke about it then at the C++ talk. There's capabilities and conventions. This plugin gives me the capability to run JS test driver. It doesn't actually give me a JS test driver task or change anything about the way my project works. Which is why if we have a look in this guy, we had to actually create our own JS test driver. So you could imagine a plugin building on top of this that says that you just need to put your JavaScript files in this particular location and I'll run them. Just basically do this kind of thing by default. Very simple to write a plugin to do that. Okay, so we have that. Now let's have a look at the task. We're not creating any tasks in here, but we can see from this guy that the plugin does provide this particular task type, which is new. So what is it doing? Here it is. It's just a simple custom task with a few different properties. What is the JS test driver jar that I should use? Where is the Java that I should use to run JS test driver? What is the config file for JS test driver? Where should I put JS test driver's output? How do I create the browser to point at JS test driver? And what port should I run on? Now, notice in here, this is the most important part. All I'm doing in here is wiring up different classes. I have a class that manages the JS test driver server, a class that manages the test executor, a class that manages doing something, launching the actual test driver, JS test driver process. So I'm using these low-level tools, these just plain Java objects, creating them and configuring them based on the task config, and then executing the process. So all of the actual hard work, all the meaty stuff is in these classes off to the side. The task is thin. It just combines the build language layer with the execution layer. It's not the actual where the meat is. It just kind of brings it together. And the implication of that is that I can easily create a unit test for this guy, which is the JS test driver server. I have a class which represents that process to launch. And in here I just use the Java Process API to actually manage launching that guy. Details don't sort of matter so much, but I now have an abstraction for that, and I can completely unit test that guy in isolation. I can throw in mocks, see what happens when, if I pass in a process, oh sorry, I need to back up a little bit. I'm using Spock here for running tests, if this looks a bit weird. Like what is this when, then, stuff, etc. So this is the Spock testing framework, written by Peter Niederwieser, who you've seen around, the Gradleware guy. It's essentially the same kind of idea as JUnit. You write tests in classes, you run them, you have assertions, etc. You see it looks pretty nice, it's a nice clean syntax, get broken up into different blocks. If you're writing tests, I highly recommend looking at Spock. I pretty much won't use anything else these days. So what we're doing here is we're creating some mock objects, passing them into our JS test driver server, doing a bunch of things and checking what happens, just like it was application code. Testing that if we give it some particular, one of the collaborators is this process factory guy that actually manages launching the JS test driver process. If we pass in some certain arguments, we're trying to test here that it actually does start on the right port, etc. But kind of whatever we're actually building, the tests are going to be specific to that. But I can test it in isolation. And you don't need any special Gradle mechanics, any kind of Gradle know-how here. That's the point. You keep as much code away from Gradle as possible, so you can just do your own testing, whether it's JUnit, TestNG, Spock, whatever kind of mocking framework you like. So I have my server, I have my executor, similar kind of thing, no Gradle API in here, just plain Java code, passing my collaborators. The browser factory guy that we've kind of breezed over, it's just an interface that can open a browser for me. So I can use this guy in my code, mock it out, etc. When I run this for real, I'm going to put in an implementation of here that opens Chrome. But you see how it's just, this is the same kind of thing we'll do in application code, introduce interfaces so things are easier to test. We can do the same thing in our build code in order to decompose it. So that what I consider my unit test. Nothing really special, just the code that's there, create mocks, call some methods, does it do what we want to do. Integration tests get a little bit more interesting in that here I'm actually testing if I can launch JS test driver. So do my JS test driver server and Java process factory things, etc., do they actually work? So I create a test configuration file just on the file system, create an example test, create some places where it can run, create an actual executor server, wire these things together and run this. We should see it actually runs. So again, the real meat of my plugin and my hard work, I can test without any Gradle knowledge. I don't need any Gradle fixtures. I don't need any help from Gradle at all to test this stuff. And that's ideal. But then when we integrate with the Gradle API, we do need some help. So this is what I would call a plugin integration test. Now, there's a terminology clash here. I disagree with the other Gradle guys. historically, that they would typically call this a unit test, and what I call a functional test, they would call an integration test. That's largely for historical reasons. If you think about it, what's going on here is that we are testing the integration of different parts. So how we do it with a plugin is we create a project object. This is part of the Gradle API, project builder. And this is where it's org.gradle.testfixtures is the package. So I get a hold of this guy. Builder returns one of these guys, and I can configure some different things. I don't have the source set up, unfortunately. You can still see the methods. I can specify, okay, where is the project directory for this guy? What's the name? What's the parent? So I can use this guy to construct a multi-project build as well. So I'm constructing like a fake minimized project that I want to work with, because what I want to do is with this project object actually go and apply my Gradle plugin to it. So this actually goes through exactly the same mechanics of applying the plugin as we would do in a real Gradle build. We now have a project object with that applied, and now I can go and interrogate the model to see what happened, see what that plugin did. If we think back to our plugin, what did we do? We created an extension, we added that to the model, that added to the project, and we set up some configuration rules. So what could we test here? Well, for one, testing that you can just apply the plugin without throwing an error is a good thing to do. There's no exceptions happen during the execution of this, but this is an output. We actually created that extension. So did that actually get created and set up correctly? So we say that every single one of these tests, we want to create one of these fake projects for each individual test. So we have this in our setup. Then we say that when we apply the plugin, we expect the extension we added to have that port. Now, this is just coming from here. I've just extracted this out into a helper method like this. And I've done this so I can get typing on this extension. Otherwise, if I did this, the IDE wouldn't know what type this guy is because he was added dynamically at runtime. So if I do it this way, then I get some nice auto-completion and lovely purple. So I'm testing, when I applied the plugin, the extension got added, and it used the default port, which is 1234. I can't actually remember where that's coming from. There. So we're testing this happened basically. After we created the extension in our plugin, we set that. We're testing that this kind of thing happened. Now that's kind of interesting. But what about another thing that the plugin is actually doing is actually managing downloading JS test driver for us. If I don't specify a version of JS test driver, let's go back to our example project. I can actually not do this. And it works. This is a very common thing that Gradle plugins do. They try and supply a default implementation of the tools that you use. So we have some stuff in our plugin. Again, using this convention mapping lazy technique to say that if the user hasn't specified a specific JS test driver, then on demand, go and use the Gradle dependency management mechanism to do this. If you want to have a look at how that works in depth, I suggest having a look at the code quality plugins in the Gradle code base. Or you can look at this example as well, it's on the USB sticks. But if you have a look at the check style plugin or the find bugs plugin, etc., they're good examples of this kind of thing. Trying to provide a default implementation of the tool and allowing the user to override if necessary. So we want to test here. What we want to test is that when somebody applies the plugin, we don't actually go and add a dependency configuration. Because we could write that code in such a way where it automatically went and added something to the Gradle model, and we didn't want to do that. So it's also about what the plugin didn't do as well as what it did do. So here we're just going and getting the list of configurations, the list of dependency configurations in the project after applying the plugin, and checking that nothing actually got added. And we had our defaulting mechanism as well. So in this test, we're testing that lazy conventional derived wiring. That after I apply the plugin, if I create a task, so I'm just going to create a new task in this fake project called JS test, a type JS test driver. Did it get the defaults? Is its port the same as the extension port, etc.? So the general idea here is you just do something to the model, then check what happened from the outside, because you have full access to it. And here I'm testing that if I actually change the extension, do all the tasks come along for the ride? So I run this guy. I don't need any kind of special tooling or anything. It's just a standard test that I can run in JUnit or TestNG, etc. The fact that I'm using Spock is not really significant here. This could be easily be JUnit. And number 4. Where do I test? Let's just go. So there's my unit tests. So I tested my plugin, tested my wiring logic, etc. Now I haven't really tested so far that somebody can really use this plugin. I've tested that it's actually done the right thing to the Gradle model. That when I applied it, I got an extension and I kind of tested this wiring of the plugin, etc. But can somebody execute a JS test driver task that they've added after applying this plugin? And for that we need a functional test. So we've gone through unit tests where we try and isolate and make the code as small as possible so we can unit test in isolation. We don't need any Gradle help here. We don't need any kind of additional stuff, so we can use all traditional things. Mockito, Spock, JUnit, nothing special. Runs in your IDE, you can debug, all that great stuff. But the thing is, that we could only do this because we actually structured our code in such a way where most of it was separate from Gradle. That's the key thing. I see in a lot of plugins, really, really large plugin classes and really large task classes where all the logic is buried in there. It means that you can only unit test it with something like Project Builder and you need all this extra stuff. So isolation. Integration tests that we've done so far. In our case, we had to manage some external processes, so we tested that. We actually used that code in isolation, tested we could launch the processes, etc. Integrated with API, and interestingly, with Gradle stuff, it's really usually comes down to using the project builder, working with the model, adding things, etc. Functional tests. The core idea behind a functional test is, can somebody actually use this? So here's what my functional spec looks like. Go away. So I've got a base class here, which I'll go through in a second. But I need to construct a build. I'm not testing a specific build. I'm testing how my plugin works in a Gradle build. So I need to construct the Gradle build, but I need to do so in such a way that it actually looks like a real build. So what we're actually going to do is here, creating our JS test driver config file, creating our creating our JavaScript 2 test, and then we create a fake build by actually writing to a build.gradle file in the file system. So here's a definition of what goes in there in our tests, and we can tweak this, change it, etc. Write that to a file. It becomes now a real build that we've generated, and we're going to run it. So what do we do here? We are applying our JS test driver plugin. We need to import this class because it's not on the list of default imports, pulling in a particular version of JS test driver. Now, I could just let the default mechanism do this. One of the features that we built into the plugin was that it would download itself. But I don't want my functional tests going and downloading things from a repository. So I was compiling against JS test driver in my code. So it's on my class path, so I just pull it off my running class path. And this guy is not doing anything too special. It's actually just looking through the current class path for that JS test driver jar. Right. So I just to avoid in my functional test going and downloading something from the network. You can do that, it's fine. Many of the internal Gradle functional tests do it. I just wanted to show this, in this case, something to think about. And this works because of Gradle's flexible dependency notation. I can refer to a file as a dependency. It doesn't have to be something up in a repository. So again, pointing out, you do need to be a little bit inventive here sometimes. So more configuration, specifying that when we run our tests, we run with Chrome, and we add a specific task to the build and wire it up. So now we have, in a temporary space on the file system, a Gradle build. We dig into this superclass, and this is kind of the mechanism driving that. If you haven't used JUnit rules before, that's what this is here. And it's just a nice mechanism for getting some test utilities in your tests. And one of the things that JUnit ships with is a temporary folder rule. Basically what that does is for each test, provisions you some temporary space in the file system and cleans it up for you afterwards. So I have that, so I now have some space to basically create my Gradle build. That's all we need to look at for the time being. And then, so now I have to think about what can we test? What makes sense to test here? I can't go in after doing this and look and have a look at the extensions and get access to the Gradle model. I'm completely outside. Right? I'm going to be running Gradle on this build and seeing what happens. I'm not inside the build. Again, similar to testing a web application, where you're clicking the front end. You don't have access to the back end database or structures in there. And I've just constructed a bit of a test DSL on top of this, and I'll talk a little bit more about when you can have this. Saying, so given this build file, given I have a build that looks like this, when I run it with these arguments, then the build succeeds. So at this point, this is actually going to run this build and verify that it doesn't end with a failure. That's all I'm testing, is that I run this, doesn't fail. Then I go and look and say, well, I'm expecting JS test driver to spit out some XML. I can't scroll to the right for some reason. Not even that way. So basically, after we run the build, we go and have a look in the build this place where JS test driver was writing files and see, did it write something there? If the build succeeded and we got this file at the end, that's a pretty good indication that everything worked. So a happy day case. Now let's just have a bit more of a look in here. Now, this stuff is what's coming. This isn't in Gradle right now. If you want to play with the early work of this, I'll show you how to do it at the end. But this is not in Gradle right now. Its API might change. This is just an example of the kind of thing that is coming soon. I'll talk more about that. But I have this object called the Gradle runner. I create one using the Gradle runner factory, and Gradle runner looks like this. I tell it, okay, which directory are you going to run in? What arguments should I run you with? And then I can actually go and run that. So just programmatic execution of Gradle. And the rest of this stuff is really just some DSL over top of that. I have a method called build script that takes a string, and I can go and write that to the right place. I have this args method that we used. I can set up the runner, etc. And at the moment, a definition of succeeds is that when I actually run this build, I don't get an exception. If I'm testing for failure, which we're about to do, I expect that we run the build, but we do get an exception. And testing for failure is important. In this case, we want to test that if we have JavaScript that actually fails testing, that the build fails. So let's actually run this. So we've got our test process here in our IDE was actually launching Gradle as a separate process, which ran this build, which ran JS test driver, which launched the browser, etc. So we're fully launching Gradle build programmatically. And failure case. So I can see here is my output from the Gradle build. And as you can probably tell by this logging, this is actually using the tooling API underneath. The same library that we use to integrate with IDEs, etc., that they can run Gradle and interact with Gradle. So this is what the Gradle runner stuff that we saw is a kind of wrapper over the tooling API, which is doing the hard work of running Gradle. And test bad JavaScript. Same thing happens. Now, it can be a bit confusing to think about because we're actually testing that the Gradle build failed, but that's a green test case for us. And it's important when you're doing this kind of testing to really think about the failure cases as well. This one's a bit simple because we're just testing that the build fails when things are misconfigured. But often you want to think about, well, what happens, so when the build wasn't misconfigured, we had failing tests. You do want to think about what happens when somebody using your plugin configures it the wrong way. Do they get the right kind of error message, etc. So testing for failure is important for plugins. So hopefully that's the general idea, is that you actually dynamically construct the Gradle build, inject your bits into it, and run it. That gives you a pretty good idea that your code is good. Now, even if I would be doing this if you have a sophisticated plugin that's even just used once in your build. Testing in isolation like this is a way to verify that it's actually working. All right. So the fundamental question is, can a user use this? Does it work? Happy day. When things go wrong, does it fail properly? Are the error messages good, etc.? You should be looking at the error messages from the outputs, etc., making sure that they make sense. Is the feedback good? Same thing. Does it integrate with Gradle properly? Is it incremental? If I rerun this task multiple times, do I get an up-to-date message? Testing those kinds of features. That really needs to be tested at a functional level. There's no other way to test the incremental build mechanism. There's no other way to test the actual execution of Gradle other than this kind of approach. So incremental build, a very important thing to test for. Does it integrate with other plugins? If I was to apply the Java plugin as well with my JS test driver plugin and they collaborated in some way, do I get the right kind of collaboration? Many things here. It can be easy to write simple cases here, but testing corner cases, you end up running a lot of methods that generate code to be compiled, such as if you're testing the Java plugin, you have to generate a bunch of Java code for it to compile in different types, etc. Depending on how sophisticated it is what you're doing. Obviously, testing a release plugin is interesting. A release plugin that pushes to some kind of repository. What you can do is something like, in your config of where to release to, specify the location of some local HTTP server that you started up, etc. Don't test releasing to your actual repository. If it's talking the same language of HTTP, you're pretty sure that it's going to work on your real release repository.
Or just mock it.
You could mock it, but how would you mock it in this case? Because you don't have access to the internals of the build. So you would have to, in that case, you would have to expose some kind of entry point in your build script to insert a mock, which your user's probably not going to want to do. No. So, yeah, you can't really mock at this level, but you can stub out entire subsystems, which is what you do when you functionally test web applications sometimes. Hard to test corner cases, hard to debug. Now, this is something that we were looking to fix, but at the moment, and probably in the first proper release of this, this is actually running in a separate process. Our Gradle build is a separate process. I can't set a breakpoint here and have the build stop. For one, it's a string. Can't breakpoint inside a string. But I can't actually step into Gradle's execution as well. So what we will do is something, some kind of way of configuring the execution mechanism to start the other process and wait for a debugger to attach, or something like that. There's something else that's going on here as well that's a bit subtle, is that we have a separate process, but we're actually using the classes from our IDE to run this. So I don't have to go and build this plugin and publish it in order to use it. Let's say that here is my method that actually goes and executes the test run. It's going to return true if things worked, false if they didn't. So the tests were all good, this method returns true. If they weren't all good, it returns false. Let's just change the code. False, always going to fail. So now when we run our functional test, where we're expecting good JavaScript to actually pass, fails. So I can actually change the code under test, just rerun the functional test. What's happening here is that the Gradle runner mechanism is basically collecting up the class path from the IDE, injecting it into this other process. So you can do this kind of thing. So largely you don't have to worry about it, it just gives you a nice development workflow for running this stuff. Alright, so I'll come back and talk about that code in a second in terms of the actual support code. Think about the testing pyramid, small amount of functional tests on top, some integration tests in the middle, and lots of unit tests. To make your life easier, you want to write your logic in such a way where you can thoroughly test it with unit tests. Don't invert the pyramid. It can be very tempting to just use nothing but functional tests. And sometimes if the code is designed badly, that's your only option. How you design for testability, I mean, if you look at the growing object-oriented software with test book, it's all the same stuff. Single responsibility, modeling, don't couple to an API. Remember when we looked at the test task, we saw all the logic was out of the test task into plain classes. It's the idea here, don't couple yourself. You don't need functional tests for everything, and don't overuse inline closures. It's kind of a subtle point. I meant to take that out as I don't have a good example. All right. In the Gradle API, we've seen lots of examples of this kind of thing, task with type test, and we do some configuration in here. All right. I want to unit test what goes on in this closure, specifically. Kind of hard to do, the closures buried in line. It might be in a larger piece. You'll see in the Gradle API that everywhere you can pass a closure, you can actually pass a real object of type action. No, it's not from swing. It is this guy, or Gradle API action. Instead of using an inline closure, we can use this guy, and we can actually make this action test. So this is now an action. Yeah, that's not right. Gradle's test task is what I wanted. So now we have the configuration that we had in that closure, as a standalone class, yep, doesn't matter, in here. So I can move my logic from that configuration out into this guy. It's a plain object. I can new it up, pass in a mock of test, etc. Previously had that buried in my plugin. And keep the real work out of tasks. Okay, looking forward. Improve supports. What are we doing to make this easier? Unit tests. The idea of the unit test is that you don't need anything from Gradle, so you're on your own. Integration tests. At the moment, you have that project builder factory for creating a test double effectively. So you can create a fake project, add the plugin to it, do all those kind of things we saw. And remember, all that code is in your USB stick. One thing that is coming is a dependency injection framework for creating tasks, extensions, etc. So that when you create them during the normal build, you get real implementations of things. And when you're creating them during an integration test, you can inject fakes and doubles. So just if you're doing Spring or Juice, same kind of thing. So a framework in Gradle for helping writing those kinds of integration tests. And for functional tests, there is nothing in the core right now to help you do this. Not strictly true, because you could write the kind of thing that I had here, but nothing that makes it super convenient as we would like. So what we want to do is provide something that's very close to what I demoed today. So I can just use that Gradle runner and Gradle runner factory to create an object to run Gradle builds. You'll still be responsible for writing your own fake builds and executing them like that. So a framework for doing that, to be cross-version, to say run this with Gradle 1.1, 1.2, 1.3, 1.4, etc. So it's quite often, with a 6-week release cycle, unless you're upgrading every build in your enterprise, you're going to have a mix of Gradle versions. So when you're writing plugins, that's going to be an important aspect of it. And IDE compatible. One of the complications with this is that we're making sure that it's very convenient to run the tests in the IDE and try to debug them. So there, we do have a design spec on this, which goes through our plans and the different kinds of things we're planning to do, and some example APIs, etc. Looks kind of familiar, so if you want to look more at that, link is in the slides. You can actually get your hands on the code that I used today if you want to play with it. It is on my GitHub page. Gradle, yep. I don't have a link to this in the slides, unfortunately. So that's where it is. It's exactly the code that I used today. And this, it's actually also in the code sample. It's basically copy pasted out of here into there. And it was basically an experiment, and it's an ongoing experiment to see how we're going to do this. Now hopefully this will be in Gradle very soon. Something we're working on. I expect 1.8, 1.9 around that time frame. It will be in the Gradle core, but if you want to have a look at it and play with it, it's there. And based on the Gradle tooling API. All right, any questions?
You're saying there's nothing in there right now. Is the Gradle launcher, is that going away? That's sort of a current way of simulating.
No, it's still there, and it's actually the tooling API actually uses that as well on the other side. That's there. The problem is, I mean, I don't see that going away anywhere time soon. But there's a few issues with that with regards to class path management and things like that. So, I mean, yeah, it kind of works, but not good enough. So that's why we're using the tooling API, but we also will support an embedded tooling API mode for doing same process. Right, so the tooling API actually can run embedded in the JVM. So all of the pieces, if you have a look at that code I have there, it's just basically driving the tooling API. And all we have to do is just kind of clean that up and sort out some memory issues, etc., to get that in. So I would suggest in the short term, if you can't wait for this in the core, have a look at this. And as I said, it's in all the code that I went through today is in your USB stick as well as the testing code. Yeah?
Do you foresee sort of an automated when the plugin portal comes around?
Yeah, absolutely.
So testing with the different variants.
Yeah. So one of the things we want to do with the plugin portal is that when you upload a new plugin, we use some kind of CI infrastructure, whether it's Travis or Drone or whether it's our own infrastructure, to automatically run your functional tests and across a range of Gradle versions. So the idea here is that, well, you should be running the test before you commit, obviously, but we'll run them so we can put a green badge and say, yes, this guy has tests that passed with this Gradle version, etc. Yeah. It's a big part of the story for us. We've had this kind of infrastructure in Gradle itself for a while, and we've been building it out because we use it to test Gradle. But we have slightly different concerns there than what you do when you're developing stuff outside of Gradle. So we have to test the actual kind of process environment, and does it work when running with a daemon, without the daemon, etc. Testing the Gradle internals. But I mean, it won't be the case that you have to upload to the plugin portal to run your tests, of course. You do it locally, but we will do it. Provide some kind of CI infrastructure. Yeah.
Well, it's just unlikely that everybody's going to have access to all of the target platforms.
Well, they're using the tooling API, right, which uses the wrapper, which can download them for you.
I wasn't talking just the version, I was talking.
Ah, right. Yeah, most plugins aren't that sensitive
Sure,
to
most
operating
are.
system. Yeah, I mean, Gradle itself is, but I don't know if I don't imagine we'd do multi-platform stuff.
Something like distribution, RPM, PNG plugins, stuff like that.
Yeah, I think you'll probably be on your own with that stuff. I mean, we're more interested in certifying things for certain Gradle versions, and so when a new Gradle version comes out, we can test all the plugins in the plugin portal, that kind of thing. But more sophisticated stuff, don't know how much we can do automatically. Interesting idea
I
though.
was also thinking plugin permutations, like even like JCoco, Sonar Runner, things that overlap with each other that have to be tested and applied in
Sure.
different orders.
Yeah. Yeah, there's lots to do for sure. Yeah.
So it's a little off topic, but I noticed you had some tests which had a hard-coded port number. And I'm wondering if you guys have run into a case where if you have lots of parallel tests running, you know, you can get port in use errors and stuff
Sure.
like that. It can be a barrier to parallelization. And if you have any ideas about how you might avoid using hard-coded ports.
It depends on the tool. Hopefully, the standard convention in Java is that when you specify the port, if you specify a port of port 0, it binds to whatever it can find, right? So if you can access, I mean, if you bind to a port in Java and you specify bind to port 0 using its API, it will pick an ephemeral port. It's guaranteed to be available. So hopefully, whatever you're using allows you to do that because it exposes that functionality.
And then you just have to find a way to capture that and
You
pass
read it
to
back out. Yeah.
Okay.
Unfortunately, JS test driver doesn't, right? So I would have to manage port collisions, yeah. So in more general, in the CI server, some CI servers have the concept of a resource, as a pool of resources, and you can model ports as resources. To say this particular job uses that resource, which is the port number, and you have to feed that in from the outside. Or you use like system property configuration, that kind of thing, yeah. Okay, thank you very much. Enjoy the rest of the conference.